In August 2018, one of the most ambitious and challenging solar system exploration projects to date was launched. Aboard a Delta IV Heavy launch vehicle, the Parker Solar Probe began its journey to our star. Exploring the sun more closely with a space probe was long considered impossible, then just extremely difficult, and now, we humans have finally done it. Our technologies have advanced so far that the Parker Solar Probe is theoretically capable of withstanding the extreme conditions of the sun for several years. Find out in this video whether this marvel of technology has really reached its orbit around the sun and what data the probe has delivered along the way. Named after the U.S. pioneer of solar exploration, Eugene Newman Parker, the Parker Solar Probe is designed to get closer to the sun than any other man-made object ever has before. Solar probes have existed in the past. For example, the Helios 1 and 2 probes approached the sun in the 1970s, but all previous probes have only been able to approach the glowing star on orbits that roughly corresponded to the position of Mercury closest to the sun. On average, Mercury approaches within 36 million miles of the sun. The Parker Solar Probe, on the other hand, will approach the sun to within 3.7 million miles. So while all the predecessor probes observed our star from a safe distance, we will now, for the first time, get data from closer to the sun than ever before. Thanks to the predecessor probes and the observations of space telescopes such as Hubble, we have already been able to learn quite a bit about the nature of the sun and solar activity. But this data was not nearly enough for scientists. Our life on Earth depends on the sun to such a significant degree that we urgently need to know more about our star. Phenomena such as violent solar flares and particle storms, which are hurled from the sun onto the magnetic field of our planet, can really shake up life on Earth. In particular, technical equipment, the power supply, radio, and satellites in orbit around the Earth are at risk from the violent solar winds. A masterpiece of engineering. From the beginning, it was clear that this probe would have to be designed and built completely differently than probes destined for missions to Mars, Jupiter, or the far reaches of the solar system. Because the Parker Solar Probe will come extremely close to the sun and fly directly through the corona, which is extremely hot in places, the probe must brave temperatures of over 2,300 degrees Fahrenheit. To make this mission technically possible, the experts had to come up with a number of ideas. First, the probe needed a housing in which the highly sensitive measuring instruments could be safely protected and keep a cool head despite the heat. In addition to the probe's insulated housing, a plate-shaped sunshield provides sufficient protection. The shield, which is around 9 feet wide and 7 inches thick, and is equipped with white ceramic and special carbon fibers, shields the probe so perfectly during all flybys that only cozy warm room temperatures prevail at all times inside, where the highly sensitive measuring instruments are housed. Despite the shield, sensors and cameras can see far enough beyond the shield to provide measurement data as well as images. In this way, NASA's solar probe can spend several hours in the inhospitable environment of the corona. For propulsion, the probe uses, what else? Solar cells. The 2 primary solar cells are located on 2 laterally mounted solar cell wings, which can be swung back by up to 75 degrees or even folded in completely for safety reasons. When approaching the sun, after passing through the hot zone, the probe moves away from the danger zone again at speeds of up to 365,000 miles per hour, cools down, uses this time for other scientific tasks, and approaches the corona again a few weeks or months later. This game of approach and retreat for observation will be repeated several times until the year 2025. This is how long the experts from NASA have set the mission duration. After that, there is no longer any guarantee that the probe will continue to function. The Parker Solar Probe already caused a sensation at its launch. The scientific director of the mission, astrophysicist Noor Rayoufi from Johns Hopkins University in Washington, D.C., commented on the launch on U.S. television with the words, "A dream comes true." Now let's see to what extent this dream will be fulfilled in the further course of the mission. The secrets of the sun. Our sun is first and foremost a huge ball of hot plasma held together by its own gravity alone, with no solid surface. Where our Earth has a troposphere, stratosphere, and mesosphere, the Sun has a photosphere, chromosphere, and corona. In the photosphere, the layer most visible to the human eye, temperatures are about 11,200 degrees Fahrenheit at the bottom and cool to 6,700 degrees at the top. These values are at first not so extraordinary and correspond approximately to the temperatures reached during welding or around lightning. The actual solar mystery is the outermost layer of the solar atmosphere, the corona. Here, about 1,300 miles above the photosphere, the temperatures of the Sun reach up to 900,000 degrees Fahrenheit, and thus 80 times more than the values determined in the photosphere. You may know this effect from a candle, where the air about an inch above the visible flame is much hotter than within the flame itself. At this point, we must of course strongly advise against you testing this by sticking your finger into a candle flame. You can much more safely verify this by seeing how quickly a sparkler ignites when you hold it in the center of the flame, and how quickly the sparkler catches fire when you hold it above the candle. Despite this similarity, the dimensions, distances, and magnitudes involved in the heat effect in the solar corona are vastly different. Researchers like to compare this kind of temperature difference to how a campfire gets hotter the farther away you get from it. Presumably, this strange temperature development is due to hot solar material rising from the plasma layer in the outer regions of the Sun and becoming extremely heated by the Sun's external magnetic field. When these extremely hot plasma streams escape the Sun's gravitational field and corona, the Sun ejects hot solar material into space at speeds of a few million miles per hour. Eugene N. Parker gave this effect the name solar wind in 1959. On Earth, the solar wind is responsible for power outages, radio wave interference, but also fascinating auroras. The particle storms are sometimes more and sometimes less intense. Although the extent has so far been tolerable for us humans, researchers fear that the Sun could one day blow a mega solar wind in our direction, which could cause us previously unforeseeable problems. Conceivable are scenarios in which the Earth's magnetic field would be massively disrupted and navigation devices, for example, of airplanes, would be strongly disturbed. Migratory animals such as birds and whales are also affected by changes in the Earth's magnetic field. If the Sun increases its wind activity permanently, this could also lead to climatic changes on Earth. Since the phenomenon became known, researchers have been monitoring the frequency of solar winds and their intensity. In the process, they were able to observe cycles that led to a certain predictability of the solar winds. But then, the activity increased in a way that did not fit at all into the picture of the data obtained so far. Shortly thereafter, solar storm activity leveled off in an equally unusual way that left researchers once again puzzled. Among other things, it is these vagaries of the Sun and their origin that astronomers and physicists now want to explore up close and personal in the field through the Parker Solar Probe. The Parker Solar Probe approaches the Sun. The probe's first really big success was its first complete flyby of the Sun's corona in April 2021. The ultra-thin corona is actually only very faint. We humans can only see it really well from Earth during solar eclipses. The rest of the time, the corona is outshone by the bright photosphere. During its April 28, 2021 flyby, the Parker Solar Probe sent these unique images of particle streams in its vicinity to Earth, measuring temperatures of about 1,440,000 degrees Fahrenheit. During the first flyby, the probe made additional measurements and then moved away from the near Sun. After a few hours, on November 21, 2021, the probe approached the Sun to a minimum distance of 5,308,118 miles. In the process, the probe was able to record unique serpentines of the solar wind for the first time. These S-shaped plasma streams, also known as switchbacks, turn towards the Sun one more time on their journey into space, then hook again and fly into space as solar wind. The Parker Solar Probe was the first to trace such a hook back to its origin on the visible surface of the Sun. As heat rises through the Sun, these convection cells are stirred up, creating funnels of magnetic energy. The S-shaped waves of the switchbacks are already formed in the funnels by feedback effects. They then maintain their wave-like expansion until they fly out to space. The mission is already a complete success. For science, the Parker Solar Probe's fly-through so far and the measurement data obtained represent a milestone in solar exploration. Humans worked for nearly 60 years to make this moment possible. One person who was particularly pleased with this success was, of course, the probe's namesake. In one of his last interviews, Eugene N. Parker expressed his enthusiasm about the mission's successes so far. Unfortunately, the great scientist will not live to see the coming fly-throughs. He died in March 2022 at the age of 94. So, we hope you enjoyed this little trip to the sun and were able to take away some new, fascinating impressions of our home star. At the end of the video, tell us what you think about solar exploration. Do you also think it's of great importance for us to learn more about the solar winds? Or do you trust the sun blindly and think everything will work out? Let us know and share your opinion with us in the comments.